Hey guys, now that's a new situation. Now there are two blocks in contact, block A and block B. There is roughness between the two blocks, but then the floor is smooth. That is, there is no friction force between block B and the ground. Now note that there are forces applied on both the blocks. On block A there is a force which is 3 Newton, and on block B there is a greater force of 10 Newton. So now you just try to figure out by use, the concepts are same. It's a new situation, but it's not a new concept. You try to find out in which direction friction force is going to act on block B. Now that is your exercise. I will just, you can just pause the video here and you can try to figure it out. Just try to find out in which direction friction force is going to act on block B. So once you have tried it out, you can just check whether you have done it correctly, whether you have shown the direction of friction acting on block B in the right direction. So this is how you analyze. Right? Now let's assume that there is no friction between block A and block B. Now friction is intelligent. There is communication that is going to happen between the two blocks. Now what is the role of friction? Friction tries to prevent relative motion that is going to happen between two entities which are rough and are in contact trying to move over each other. Now because of this force, which is 3 Newton acting on block A, having a mass of 1 kilogram, now this will try to move forward with an acceleration of 3 meter per second square if there is no friction between the two blocks. So let us assume that there is no friction, that intelligent agent is not operating between the two. Now when there is no friction, acceleration of block A would have been 3 meter per second square. So I'll just write it out over here. So acceleration of block A, I'll call it as A1. That is going to be 3 meter per second square when there is no friction. Now similarly, when you apply 10 Newton force on a 5 kg mass, and if there is no friction between A and B, now this would have had an acceleration of 2 meter per second square. Now you might have, if you have done something like this, now say this is a greater force, this is a smaller force. Since there is a greater force acting on block B, so friction on block B must be towards left. Now that's not the right way of approaching it. You try to see what happens. How will block B communicate to block A? Now when block A tries to go forward, block B will try to prevent block A from going forward. Now note that this 3 Newton force which is acting on block A, which has a mass of 1 kg, now this will try to generate an acceleration of 3 meter per second square, whereas this force will try to generate an acceleration of only 2 meter per second square on this 5 kg block B. So now here on block A, this force, since it tries to generate a greater acceleration, so it is happening like this. Block A tries to go forward on block B, and block B communicates to block A that no, I'm not going to allow you from going forward, and it will try to prevent block A from going forward by applying a friction force in this direction. Now in turn, because B has applied a force on block A in this direction, now A will exert a force on block B in this direction. Now what does this force try to do? This friction force acting on block B, that friction tries to take block B forward with a greater acceleration. So this friction force will try to reduce the acceleration of A from 3 meter per second square, and this friction will try to increase this acceleration from 2 meter per second square, and it will balance both the accelerations and it will take both together. Now that's why friction is intelligent. It tries to prevent the relative acceleration between the two blocks by making both the blocks move together to as much an extent as possible. So the correct answer would be on block B there will be a friction force towards right, and on block A there will be a friction force acting towards left. Right? I hope you have understood the concept a bit about friction. In fact, there are so many more cases that you can try to draw, get the values of friction in so many different cases. That's for a later time. Okay? Thank you guys.